Up to this stage, we have discussed how to establish the decision context. We identified a long list of options and some criteria for assessing them. And in the next section, we will discuss how to score the options on the criteria. And as usual, we start with talking about the old friends who are going out to eat. They have a list of places by now. Let's call them A, B, C, D, and E. And a reminder of a list of criteria. One of them is vegetarian, and they're also interested in a good location, relatively affordable price, and quietness so that they can catch up. So what do they do now? They have to evaluate the cafes on these criteria. Let's say that they check all the places, and D and E have nothing to eat for vegetarian people, so they exclude them immediately, and at the same time exclude this criterion. So what remains is location, price, and quietness. And how can they decide, how can they score the cafes on these? For example, location, they can look at the map, measure distances from local transport and from their homes. Price, they can check out on the online menu. And quietness, they can also determine by checking out how far apart seating is located and reading the reviews online. And when they evaluate all the cafes, they will know all this information about each one of the options. And if they put it in a table, it's probably unlikely, but if they do, it will look like this or something similar. Where the price is in some monetary units, the quietness is described as either quiet, very quiet, or a little bit noisy, and location, let's say, only either really great or just okay. And something similar will happen in the TNA. Consultant will be in charge of this step, and sectoral working groups and wider stakeholders will support them. And the activities involved will be consultations, discussions, and a thorough desk study. And the process can start with a desk study. The consultant can check what is available, what kind of information they can find on these technologies that they have selected in the list of options. Is it possible to find quantitative or qualitative data to describe how well these options perform on the criteria? And if not, they can use either consultations or discussions to obtain expert judgments on these criteria. Consultations and discussions can also be used for validation of the data found in the desk study. It is also important at this stage that the consultant notes down the discrepancies in the expert judgments and also any uncertainties in the data, modeling or field study that they might do at this stage, because this might be useful to do in a later stage to check for sensitivity of results. So some data will be quantitative, some qualitative descriptions, and the rest will be expert judgments. And the consultant can organize this into a performance matrix. In the performance matrix, options are in rows and criteria are in columns. And for example, there can be quantitative values like emission savings in it, and there can be expert judgment values such as water savings expressed in either low water savings or high water savings. So as you can see, the scale in the performance matrix is different for different criteria. We have, for example, kilograms of CO2 equivalent saved per ton of yield. We have 5-point scale. So we still cannot add the scores and obtain a single score for one option. This is solved in a normalization procedure. In the normalization procedure, what happens is that performance matrix is converted to a normalized scoring matrix. And in a normalized scoring matrix, the most preferred option for each criteria has a value of 100. And the least preferred has a value of 0. If you are using the MCA Excel template, this will happen automatically and you don't have to worry about it. But the way this is done is using this formula. For the criteria where the high value is preferred, for example, emission savings, this formula is used here. And the one on the right is used if the low value is preferred, such as, for example, costs. I'll just follow the example that we had for the performance matrix. When it is normalized, it will look like this. So the best emission savings are option C, and it becomes 100. The lowest emission savings, of 100 will become 0 because it's the worst performing option among the 4. And similarly, with water savings, there are only 2 points in this scale, and therefore we get only hundreds and zeros. And this is why it is important to select scales which are a bit less coarse than this one, because in this case we don't have enough information to distinguish between these options. There are 2 zeros and 2 hundreds. It is best not to end up with such a scale, but if you have, for some reason, you can still, after normalization, consider, for example, these 2 options B and C. Which one of them is better? And you can adjust these after the normalization procedure. So these values here, 20 and 80, in this example, are not normalized but provided by value judgment. So to summarize the scoring, what will be the output? It will be a matrix with scores for each option. And both performance matrix and the scoring matrix will be part of your TNA report. And with this, we complete the scoring section of this module.